Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today. It's a problem for exam FM, Financial Mathematics. A perpetuity provides for continuous payments. The annual rate of payment at time t is 1 for t between 0 and 10, and 1.03 to the power t minus 10 for t greater than or equal to 10. Using an annual effective interest rate of 6%, the present value at time t equal to 0 of this perpetuity is x. Calculate x. We separate this perpetuity into two parts. First 10 years and the rest. And then the present value at time 0 of the payments from the first 10 years, that's just a unit continuous annuity paid over 10 years at the interest rate of 6%, but it's a continuous annuity. So the formula for its present value is 1 minus v to the 10th over delta, where v is the discount rate over 1 year, so it's 1 over 1 plus the interest rate, so it's 1 over 1.06. So 1 minus v to the 10th is 1 minus 1.06 to the negative 10, but this needs to be divided by delta, and of course delta, the force of interest, corresponding to the interest rate of 0.06 or 6%, is the natural logarithm of 1.06. So once we write this all out, we can calculate that this is approximately 7.5787455, or 758 approximately. Well, the present value at time 0 of the payments from time 10 all the way to infinity is the integral from 10 to plus infinity of the rate of payment is 1.03 to the power t minus 10. Discounted to time 0, that's 1.06 to the minus t dt. And now we make a substitution in this. We write s to be t minus 10, then ds is equal to dt. And when t is 10, s is 0. When t goes to infinity, s goes to infinity. So this becomes the integral from 0 to plus infinity of 1.03 to the power s times 1.06 to the power minus s plus 10. And we can factor out the constant 1.06 and negative 10, but then the integral is with respect to s. So this becomes 1.06 to the negative 10 times the integral from 0 to plus infinity of 1.03 divided by 1.06 to the power s ds. And now a very important observation, that if we were to express the force of interest corresponding to this expression that we have here as a discount factor. So 1.03 divided by 1.06. Think about it as a discount factor of 1 year. Then that would be e to the minus delta. Then what is delta? That's the key question. Because then this becomes a present value of a continuous annuity, actually perpetuity, from 0 to plus infinity. So that delta is the natural logarithm of 1.06 minus the natural logarithm of 1.03. And then if we do this, then this becomes the integral from 0 to plus infinity of e to the minus delta ds, delta s ds, which is a bar angle infinity at that force of interest delta. So it must be equal to 1 over delta. But delta is ln of 1.06 minus ln of 1.03, so this is equal to 1 over natural logarithm of 1.06 minus natural logarithm of 1.03. so that the present value at time 0 of the payments from time 10 all the way to infinity is 1.06 to the negative 10, the thing that we factored out, divided by natural logarithm of 1.06 minus natural logarithm of 1.03, and that's approximately about 1945. And if we add the two present values, we get about 7.58, 19.45, and the sum is approximately 27.03, which is answer A. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.